All right, hello. Welcome to another AP Calculus lesson on Taylor series. We're going to be basically finding the sum of Taylor series based around kind of the information that we know. So we're going to start off with a couple problems. They're going to be a little bit long. So I want you to try and find the sum. Now I'm going to be pausing the video, but most likely if you're watching this on YouTube, I'm going to be cutting out all of those types of things. So if it might seem a little weird or kind of a little jank at some points in time, that's probably why. So I want you to find the sum of this example. So 1 plus 3 over 1 factorial plus 9 over 2 factorial plus 27 over 3 factorial plus dot 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 plus 3 to the n over n factorial plus dot 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 dot. So if we take a look at this series, we notice that this is my general. And if I just see that each one of the values up top, right, are changing, right, this is 3 to the first, 3 to the second, 3 to the third, and then also 3 to the n. But if I take that 3 and change it to x, so that'll be x to the n over n factorial, we know that to be actually e to the x. So this is really just saying e to the third is going to be our sum. So what we're trying to do here is we're trying to be able to see patterns in relationship to some of the Taylor series values that we figured out, and then we're actually able to figure out what the sum is by converting them, in a sense, back to the original functions rather than the expanded versions of the Taylor series. All right, let's take a look at another one. 2 minus 8 over 3 factorial plus 32 over 5 factorial minus 128 over 7 factorial plus dot 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 plus negative 1 to the n plus, well, just actually n, 2 to the n plus 1 over 2n plus 1 factorial, and then plus dot 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 dot. Okay, so taking a look at this one, we can see that the values right here in the beginning, right, they seem to be going up a lot, but we can also see that, in a sense, this is 2 to the first, this is going to be 2 to the third, this is 2 to the fifth, and 2 to the seventh. And since those are going up by, in a sense, 2 for their exponents each time, and then, right, this is actually 1 factorial, 3 factorial, 5 factorial, 7 factorial, this is actually just going to be sine of x, and then more specifically, the x is now just going to become sine of 2. And so that specifically is our sum. All right, one more. So 1 minus 2 thirds plus 4 ninths minus 8 over 27 plus dot 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 plus parentheses negative 2 thirds to the n, and then plus dot 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 dot. Okay, see if you can figure out the sum. So if we look at this specific type of problem, I'm going to focus on specifically this section. And if we can see kind of how this goes, right, then it's actually changing by multiplying by negative 2 over 3 each time. So multiplying by negative 2 over 3. And if I'm multiplying by some type of value by the previous value, then this is actually going to be a geometric series. So a is going to be equal to 1, which is also the first term. R in this case is going to be negative 2 thirds. So I'm going to write this as the sum equals 1 over 1 minus r, which is going to be negative 2 thirds. And that's going to actually end up giving us 1 over 5 thirds, and then flip that, so that'll be 3 fifths will be your sum. Okay? Now, this next example, this one's going to be a little bit weird. So I'm going to give you some type of power series. We're not exactly going to know how this is actually going to be set up, and I'm going to actually change the variables a little bit. So I'm going to say k is equal to 0 for a sub k, right? So some type of first term, or many terms in front of the coefficient that's in front of this. So x plus 3 to the k power. So it's changing by each time. All right, so this would be, in a sense, so a sub 1 plus actually, this would be a sub 0 plus a sub 1 parentheses x plus 3 to the first power plus a sub 2 parentheses x plus 3 to the second power plus dot 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 dot, and then so on and so forth all the way up. But the only issue is that we don't know what a sub 1 is, a sub 0, so on and so forth. But what I do know is it converges when x is equal to negative 8, but diverges when x is equal to negative 6. Now, what we're going to do here is we're going to figure out, even though we don't exactly know what the series looks like and how it's kind of set up, we're going to try and figure out whether certain values are going to be actually, it's going to make this series converge or make it diverge, right, when we place in x values. So if I place in, let's say, a negative 8 into each one of these x's as it goes up, right, that is going to make a convergent series. But if it is negative 6, then it diverges. So how do I explain this? How do I set this up? Oh, excuse me. This isn't supposed to be negative 6. This should be positive 6, not negative 6. So what I'm going to first start off with is I'm going to figure out where is the center of the series. And looking at this section right here, this says x plus 3, so it is going to be centered at exactly 3. So I'm going to do a nice little number line. I'm going to place 3 right smack in the middle. Now, I do know the series converges at, well, negative 8. Actually, it's not centered around 3. It's actually centered around negative 3, right? Because, right, it would normally be minus whatever your c value is. But in this case, this would be negative, negative, and that would be negative 3. So I know that it converges at negative 8. So I know negative 8 is a good bet. I know this interval right here is going to be 5. So that means that if I take a look at the other unit 5 units away from that, that one should also work out too. Now, I don't necessarily know if the endpoints are going to be good with this, but since I do know negative 8 is good, so should 2 in terms of the radius of convergence. Actually, no, that's not true, because remember how the endpoints could be slightly different. But I do know that once I go out to 6, right over here, 6, this is divergent. And if I think about kind of in the opposite direction, so this unit right here is going to be 9 units, and then if I go 9 units away from there, let's actually make it so that it actually hits somewhere right here. So if I go 9 units away from negative 3, that's going to give us negative 12. So that I know that if I have a value that's at negative 12, I know it's going to be divergent. So I know that at least the series is going to converge from negative 8 to 2. And then it might converge between negative 12 and 6, but we're not sure if it might. So this series converges for the interval negative 8 to 2. So let's kind of think about certain values. So if I were to say x is equal to, let's say, negative 10, does this, so is it true? Oh my gosh, I don't know how to spell true. Is it true? Maybe true? Or is it, in a sense, false? Or it can't be true. So can not be true. So if I were to give you, let's say, negative 10. So the series converges at negative 10. So we're talking about, in a sense, this section right here. Well, since it's not within the series of convergence, it's outside of that. So it might converge. So this may converge. But we don't necessarily know if it actually does for a fact. Okay, let's try number B. X is equal to 1. So if this is 1, I'm talking about the value that is right here at this section. and see how that's within that radius of convergence. If we know -8 is convergent, then we know the interval on the opposite side to 2 is going to be convergent. So this is convergent. So is convergent. Or is convergent. Letter C. If I say x is equal to 2. Now, I kind of mentioned this before, right? So I can say that at -8, it converges, right? But I don't necessarily know at 2 if that is specifically the endpoint and the radius of convergence is 5, if that endpoint actually may end up converging or not. So it may be true if it converges. And then letter D, the power series diverges. So I'm going to say that it's going to diverge at x is equal to -9. So if I make that statement, so right here. Now, it is outside the radius of convergence, but it may not necessarily diverge. I know that it does diverge at 6, but I don't know necessarily about this interval right here in this kind of like hot pink region. And then same thing over here. I don't necessarily know what happens in those sections. Does it converge? Does it diverge? Well, I don't necessarily know. So does it diverge at -9? Well, maybe. Or maybe it actually doesn't, and it converges actually there. And then letter E, if I give you x is equal to -13, so -13 is right here. Now notice how that is outside that window, and I know that it specifically diverges at 6. So that means that if I go outside that window, so if I go outside this window in this region, and then I go outside this window in that region, then I know that it's definitely going to diverge on the endpoints. So so if I said x is equal to -3 diverges, then I know that this is always going to be true. Always true. Or matter-of-factly true. Is it true? It is true. Must be true. All right. That's my lesson for today. Hope you enjoyed it, and thanks for watching.